Okay, this is the Valentine's Day Massacre Reach Back of 20 questions. It is focusing primarily on grade 8 learned material as well as grade 7 learned material on algebra, fractions, integers, percentages, and area. Okay, utilization of formulas. So we have 20 questions. We'll start with question 1 here. The question just says half of a third. And what you're supposed to know is that a half looks like that as a fraction, and a third looks like that as a fraction. And the word of is multiplication. So half of a third, when translated numerically, becomes half multiplied by a third. So your final answer will be 1/6 because, of course, you multiply your numerators and you multiply your denominators when multiplying two fractions together. If I wanted to draw it, and I actually drew a third, right? If I drew a third, I'd say, give me half of that. I'd say, well, this is half of a third. And the third was cut into three pieces. Now it's cut into six. And if you had half of it, you had this one piece out of the six, which is 1/6. Question 2 says 2/3 of 1 1/2, which translated would be 2/3 of 1 1/2, or the multiplication of a fraction by a mixed fraction. The easiest thing to do is to multiply by the improper version of the mixed fraction. When you have that, two options. You can multiply your numerators, multiply your denominators, and get 6/6, which is equal to 1. Alternatively, you could have cross-reduced. 2/2 will reduce down to 1/1. 3/3 will reduce down to 1/1, and you'll still get the final answer of 1. Question 3, 1 1/5, so 1 1/5, divided into groups of 1/10. So that is what the question would look like. And if you did it without calculating it as an algorithm, what we wanted you to do back in grade 8 is be able to estimate this without actually using an algorithm. So if I think about money, 1 1/5 dollars would be $1.20. Divided into piles of, and then 1/10 of a dollar is 10 cents. So if I rethought this money and correlated it to something we all understand in terms of numbers is money, $1.20 divided into piles of 10 cents. How many piles could I make? I could make exactly 12. So without using an algorithm, you could just think of it that way, and it's exactly 12 piles. If you did actually convert this into an algorithm, you could say 6/5 multiplied by the reciprocal of a tenth, which is 10/1. When you cross-reduce this, you would say, well, 10/5 will reduce down to 2/1, which means I'm going to get 12/1, which is equal to simply 12. Same answer. Question 10, the sum. So right off the bat, you have to know the sum is addition. The sum of a half and a third. So here we're going back to grade 7 with addition of fractions. You need common denominators when adding. So the common denominator, the first multiple 2 and 3 share is 6. The equivalent fraction to a half that has a denominator of 6 is 3. And the equivalent fraction to a third that has a denominator of 6 is 2. Now that we have common denominators, we would add the numerators and keep the denominator, which means our final answer is 5/6. So the sum of a half and a third is 5/6. Removing a half from 7/10. Now this is kind of complicated because the first fraction you see is a half, and the second fraction you see is a 7/10. So if I say a half, and I see 7/10, which fraction goes first? Because it's important that you say which fraction is it. So you're removing a half from 7/10. So when we think about the order of our fractions, it's removing a half from 7/10. That's what we have to have for our question. Common denominator will be 10 because we're subtracting. 7/10 take away 5/10 is 2/10, which in lowest terms is a fifth. Question okay. Question 6 says a quarter of the sum. A quarter of the sum. A quarter of the sum. A quarter of the sum of a third, sum of a third and 2/5. So when I translate this, this is going to be the sum of a third and 2/5. And if I multiply it by a quarter, that's going to be a quarter of that. Now, alternatively, Alternatively, you could have done this. You could have said the sum of that, and a quarter would be dividing it by 4. Both of those would be the same, but we're going to keep it with the multiplication of a fraction. So we have a BEDMAS question. We're going to do our brackets first. 15 is our common denominator, so 5/15 is equivalent. 6/15 is equivalent. 11/15 is the sum. So a quarter, oops, that's not, a quarter of the sum will be that. Now I just have to multiply my numerators and denominators. I get 11 over 60, which is your final answer. No. Question 7. We have a BEDMAS of integers question. It says -10 take away the product of 10 and -2, or 10 times -2. So -10 take away whatever this is right here, and 10 times -2 is -20. So notice how the subtraction sign is still a subtraction sign, and the product of 10 and -2 is -20. And because I have a negative integer and a subtraction sign still, I have to use brackets, right? And most of us, when subtracting integers, like to keep the first integer, change it to addition, and the opposite of the second integer, in which case we would have a final answer of +10. Question 8, we have -1 plus the product of -2, -3, and -4. So I'm going to first multiply those three integers together according to BEDMAS. I'm going to bring down this because I know that's the first thing I should write. -2 times -3 is +6, and +6 times -4 is -24. Now we have the sum of a -1 and a -24, which is -25. Question 9, we have 5 take away 13 divided by -2. Now remember, if I wanted to, Jack asked yesterday, not Jack asked yesterday, if this is the same thing. So just to be clear, this is the same thing. If you have a numerator that is not simplified and you need to divide it by -2, that is one way to think about it. But another way we can think about it, correlating it to what we're currently working on, is we can think of this -2 and we can actually utilize distributive property. We could divide both parts by -2, just like we would in this particular one here, -2x squared plus 2x divided by 2x. Here, almost the, or actually I should put takeaway just to keep it completely relevant. Here, we have almost the exact same situation where we're dividing each of the terms above it by 2x. This is how we would solve a polynomial equation of dividing a polynomial by a monomial. But applying that same distributive property idea, we could technically divide 5 by -2, which is -2.5, and -13 divided by -2, which is a +6.5. And when we combine those together, we get a final answer of 4. So if you utilize distributive property, you would get the answer of 4. If we simply used this idea like Jack said yesterday, can we just subtract the numerators? So 5 take away 13 is -8, and -8 divided by -2 is a +4. So either way you do it, you end up with a +4 answer, right? But be aware that distributive property of non-algebraic polynomials, like 5 take away 13 is actually just, it's not a polynomial, but it's an expression divided by -2 could be utilized with distributive property. Question 10, halfway through. We have a BEDMAS question where it says -10, and we have square brackets, which of course we know means multiplication, but we don't write the multiplication sign. We know that it's inferred. 2 take away -3 in brackets. So we're going to first do that. And the reason why the square brackets are here as opposed to round brackets is because within those we have brackets already, so we differentiate between the small circular brackets with the square brackets so they don't look the same. So my next line will be -10 multiplied by, I can switch back to round brackets now because I'm going to simplify this, 5 plus 50 will become -50 plus 50, which will become 0. Question 11, we start getting into our algebra. Here we have a grade 8 question where we have a one-step algebraic equation with a coefficient of -2. Now, since this means -2 times the value of x, we know that the opposite operation of multiplication is division. So to isolate the variable, we will divide both sides by -2, and x will equal positive 6.5, or half of 13 is 6.5, and a negative divided by a negative gives us a positive. Question 12, we have a two-step algebraic equation, and we have a constant, and we have a fractional coefficient. And by fractional coefficient, I mean if I had to write this with a different coefficient, this red equation would be the exact same thing. So here, makes it a little bit more clear, we have a 10 as a constant, and we have a negative 0.5 or a negative half coefficient. So in two-step equations in grades 7 and 8, you learned the first thing you should get rid of is the constant, then the coefficient. In grade 9, you're going to learn that you can get rid of both of them at the same time if you'd like, or at least the coefficient first. But we're going to get rid of that constant by subtracting 10 from both sides. I'm going to have a negative half of x. Notice when you have this negative sign left here, you could put it with the numerator or the denominator. It's always best to put that negative sign with the denominator, because on this step here, I'm going to multiply both sides by -2, and x will equal a positive 40. Question 13, again, we have a two-step equation. I've just reversed what side the variable's on. We still have a 10 as a constant, and we have a -10 as a coefficient. This is a little bit easier. First thing I want to get rid of is my constant by subtracting 10 from both sides. I have 2 is equal to -10x. Dividez-vous both sides by -10, and x will equal -2/10, or -0.2. Of course, you could have got that if you just went 2 divided by 10. Bob's your uncle, right? A negative, positive divided by negative. I knew that. Question 14, we have a distributed property question, similar to if I gave you -2x multiplied by, in grade 9, 4x minus 3, we would multiply both parts of that polynomial by -2x. In a simpler way, when we use it to isolating variables, we could still expand it by multiplying both sides by or both parts of the bracket by -2, or the algebraic expression. So we have -6 plus 2x equals 16 when I expand it. Once I do that, get rid of my constant. 2x equals 22. And finally divide both sides by 2 to get x is equal to 11. Question 15 is a grade 5, 6, and 7 question. Two ways you can do it. You can do it mentally, or you can do it with a calculation or calculator. If you did it mentally, 10%, you move the decimal one spot. So if the decimal was there, 10% would be $12. 1%, you move it 2 spots. So 1% would be $1.20. And therefore, 2% would be $2.40. So if I know that 10% is 12 and 2% is $2.40, adding those together would be 12%. So therefore, our answer would be $14.40. Alternatively, if I translated this into decimals, 12% as a decimal, well, 12% as a fraction is 12 hundredths, and as a decimal is 0.12. Of course, is multiplication. So if I did this in a calculator and said, what's 12% of $120, it would also say $14.40. Either way, you got the same answer. Out of curiosity, how many did it the mental way? How many did it with a calculator? How many didn't do it? 8 people. Perfect. Question 16, if we did it mentally, remember 10%, you move the decimal one spot. So if the decimal's here, 10% would be $6. 5% is simply half of 10%, which means the answer is 5% is $3. Alternatively, 5% is 5 hundredths, which is 5 hundredths of $60. If you multiplied 5 hundredths by $60, you get $3. Jacob. Question 17 asks to take that 15% and figure out what the cost would be. Now, if I was to think of this coat as the cost of the coats, this is $80. Okay, this is 100% of the cost of the coat, $80. If I was to add on this 15% tax, 15%. So the cost of the coat being $80 is 100%. The tax is 15%. So if I think of it two ways, I could calculate that 15% and add it on, or I can think about what is 115% as a decimal. Well, I know that 15% is 0.15, and I know that 100% is 1. So if I think of this as being 115% of $80, then this one-step equation or expression or multiplication statement should give me the answer. So 115% of an $80 coat is $92. Now, alternatively, if I calculate 15% of $80, 10% is 8, 5% is 2, that would be $12 tax. If I added those two together, I'd still get $92. But this is the better way of thinking of it, right? Now, with that same idea with question 18, if I think about this as being the cost of the game, the $60 game. This is the 100% of the game, $60. 100%. If I have a 15% discount, then I'm going to lose 15%. And the game is only going to cost me this much. So what percent of the game's original cost am I really paying for if I lose 15% in a discount? So I will only be paying for 85%. So 85%, oh, that's not the right marker. 85%, is that game going to work? It's going to be 85% of the original cost of the game, 60, which means 85% of $60 is $51. So therefore, it's going to be $51. Now, alternatively, if I didn't do it that way, I could actually figure out that 15% of $60 is 10% 6, 5% 3. That'd be $9. So $60 take away $9 is still 51. And our last two questions are your area questions. Now, if I was to give you just this question and say, what is the area of the square? Well, the formula for the area of a square is side squared. But we don't have that. We're actually missing all of that circle. So if I asked you to calculate the area of the gray, it's the area of the square. Take away the area of the circle. If I think about what that formula would be, the area of the entire square, take away the white area of the circle, would be what's left in the gray. So the formula for a square is side squared. The formula for a circle is pi r squared. So the formula that you get 1.4 is coming up with the formula side squared minus pi r squared. Now that that's given, let's bring this down a bit here. Okay. So what is the side length of my square? Well, this is 12, so this is 12 as well. So 12 squared is the area of the square, or 144. Take away pi r squared. Now 3.14 multiplied by the radius. If the diameter is 12, and the radius is 6. So 6 squared would be what we have here, or 3.14 multiplied by 36, which is too complicated for me. 36 multiplied by pi. Do I have a pi button on here? Yes, I do. Let's just use 3.14 though. 113.04. So when I use that finally and take my calculator and go, what's 144 take away 113.04? The answer is 30.96 square meters is the gray. Approximately. And the reason why we use that approximate symbol is that we did approximate pi because we did declare it to be 3.14 when in fact it's a non-terminating, non-repeating decimal. So its approximate area is 30.96 square meters. And finally, your last question, which is similar to that one. If I didn't have this square here, the area of that gray would be pi r, or would be base times height divided by 2. But because we have part of it cut away, we're going to have the triangle take away half of a square. We're not going to call it that. We're just going to call it half of a square, which is half. It is a triangle. You're right. So we have base times height divided by 2, which is your formula for a triangle. Take away side squared divided by 2. Does that make sense? Right? So 12 times 12 divided by 2. Take away 4 squared divided by 2. Half of that, because it's only half of this square. So 144 divided by 2, 144 divided by 2 is 72. 16 divided by 2 is 8. So 72 take away 8 is 64 square meters.